I will talk about the three multiplexing methods: time division multiplexing, statistical time division multiplexing, and frequency division multiplexing. The Latin root plex means woven together or twisted together. For example, the word complex means many different parts are twisted together to make a thing complicated. Multiplexing in network means multiple signals are combined together and thus travel simultaneously over one link. Thus, the purpose of multiplexing is about sharing. TDM is transmitting different users' digital signals over one link or one media by dividing time into slots or intervals and assigning them equally among these different users. Let's look at one example. Suppose there are three different users to send their data. At the transmission end, the multiplexer divides time into different segments, which we call time slots or intervals, and assign them equally. They can be sent simultaneously. At the receiving end, the demultiplexer separates them. The main feature of TDM is equality. Every user is allocated with the same amount of time, but equality is not efficient in many situations. For example, some users may have more data or higher priority than others. Giving the same amount of time regardless of their need and priority is not cost-effective. That's why we need a new method, statistical TDM, or simply statistical multiplexing. Statistical multiplexing analyzes statistics related to the workload, need, or priority and determines on the fly how much time each user should get. Let's take a look at the same example, but this time the user B has more data to send or has higher priority than both user A and user C. The multiplexer decides to give user B most time slots and the least time slots to the user A. Compared with the time division multiplexing, we can say statistical multiplexing is more efficient and more in control. FDM is a different multiplexing technique. It deals with analog signals, not digital signals. Look at this example. Three different users are sending their data over the same channel. FDM combines these signals together and sends them simultaneously as they travel separately in their own non-overlapping subchannels. In summary, FDM is about a frequency channel and each user uses its own non-overlapping frequency channel. TDM is about time allocation. Every user is given with the same amount of time in TDM or different amount of time in statistical multiplexing. You may ask, when do we use TDM and when do we use FDM? To answer this question, we need to know about baseband and broadband. Baseband deals with digital signals. Baseband systems can transmit only one signal at a time. Digital signals occupy the entire bandwidth, which means baseband systems requires an exclusive use of the channel's capacity. When I use a wire, no one else can use it at the same time. Ethernet is an example of a baseband system. TDM and statistical TDM are used in baseband system. Broadband transmissions deal with analog signals, which are in the form of optical or radio frequency waves. Broadband allows multiple transmissions at the same time. They can share one channel by using different frequency range. Thus, FDM is used in the broadband system. I hope this